Well, greetings, mathletes, and welcome back. Today we're going to be looking at completing the square. Now, some of you may have seen completing the square before. What you may not have seen is completing the square being used to graph functions. So that's what we're going to be taking a look at today, is using completing the square to be able to graph functions. So let's take a look at what we're talking about here. Okay, so what we are dealing with is taking a function that looks like this. Oh, not equals 0. Habit. So we want to take a function that looks like this, and we want to transform it so that it looks like one of those function transformation versions of it. Right? So we want to change the form of the quadratic function that we're dealing with. Now, one of the things that's actually kind of nice, the whole idea of completing the square takes advantage of this little fact. If I have something like x plus 3 and I square it, right? And I'm not going to go through the whole process of squaring it. I'll let you do that. But the answer you get ends up being this, right? X squared plus 6x plus 9. Now, if we look at this, there's a relationship here between 3, 6, and 9. And it's not just going up by 2s. I want to point this out because this is going to happen every single time. 6 is this 3 plus itself. 9 is 3 times itself. If I take another polynomial, right? If I take something like x plus 5 and square it, what I end up with is x squared plus 10x plus 25. Again, if I look here, this is 5 plus 5, and here, this is 5 times 5. That relationship always holds true. As long as this first number is a 1, we can actually do that. And that applies over here too. This has to be a 1 for this to work. But we can always induce a 1. And so that's what we're going to take a look at, is how to get a hold of these things. So we can take and create something like this so that we can have a perfect square, so we can make this term, right? So that was a lot to take in. It's going to be a lot easier to see once we actually start doing it. So let me go ahead and get this off of here, and we'll look at our first example. We'll actually walk through the steps one at a time here. Okay, so let's say we have the function g of x is equal to x squared plus 6x plus 3. Okay, and we want to take it because this is in our ax squared plus bx plus c form. I'm going to call that quadratic form. They're both quadratic forms, but your book doesn't give that one a name. This one your book calls the standard form. I have heard that elsewhere called the vertex form. So, the names are kind of interchangeable. But in any case, I'm going to call this standard to match your book. And then I'm just going to call this quadratic, just so we have something to talk about. So we have words we can use. So this is how it works. So you start out by separating this 3 from the body of x's. So we have these x's over here. And then what we're going to do is just separate out this 3. Now, what we want is we need to figure out what goes in here. It's one of those things. What you're going to do is use that property that we saw before. If this part is going to be a perfect square, whatever this is has to be double whatever's being added or subtracted to x, and this one has to be the square. So what I can do is take half of 6. So I'll take 6 and divide it by 2 to give me 3, right? And then I take the 3 and square it. So I take half of the middle term and square it. So if I take half of 6, that's 3. If I square it, it's 9. So I'm going to add 9 here. Now there's a problem. I can't just willy-nilly add 9 because that changes the function. So what we do is we also subtract it out at the same time. Now, if you notice, if I add those together, I get 0. But we're going to be looking at it a little bit differently. I'm going to take this piece by itself. And you notice this was actually one of our examples. If we have set this up correctly, this piece will be x plus whatever half of that is. And you keep the sign. So if that was a -6, it would be -3. So this sign comes down, and then I take half of this, and it should be that squared. Now, if you're not sure, take this thing and square it out and make sure you get this back, right? Now, these pieces are still here. I still have a -9 and a +3. And so now I can just collect those two together. So we've transformed f of x to be, or excuse me, g of x. Sorry, I looked at the formula I put at the top of the page. There we go. We've transformed g of x from looking like this to looking like this. X plus 3 squared minus 6. And from here, I can actually read out the vertex. I can see that the vertex is at the point, it's always the opposite of this. So it'd be -3, and then the same as this one. So it's -6, right? So I can actually pick out the vertex this way. I can figure out what the vertex is from this quadratic form by switching it to standard form. And like I said, standard form is often called the vertex because in standard form, the vertex is at the point HK, right? You notice this is a -h, this doesn't have a minus. And what that means is that this h up here and this h here have to be opposite signs, right? So pay attention to that. That's actually one of the easiest slip-ups to make is screwing up that sign. So make sure you understand how that fits together. Okay, so let's take a look at another example here. All right, now this next example here, if I take, let's say I have h of x, and h of x looks like this. Okay, so we have the same issue. We need to separate out that 5, right? So now this one's going to get a little more complicated. So we have 2x squared plus 6x, and then I'm going to put the +5 out here. I'm going to give myself lots of room. Okay, so remember this is all h of x equals. I'm going to probably neglect to write the h of x in the steps. Now, we need to figure out what to do with this. The problem we have is that this 2 is out here. The method we saw in the last thing worked because we had a 1 as our leading coefficient. This time we have a 2. So what we're going to do is we're going to factor it out. So I'm going to pull that 2 out, and that gives me an x squared plus 6x, and then I'm going to leave my big space and put my +5 here. Okay, now I have a 1 here, which means I can go through the completing the square process. Oops, I just realized I didn't, I made a classic boo-boo there. You're supposed to pull the 3 out of here, or excuse me, the 2 out of the 6 also, so that should be a 3. I actually wanted that to be blue. Let me switch that back to blue. Okay, now we need to figure out what to add in here. Now you notice 3 is a fraction. Or half of 3 is a fraction. So if I take half of 3, it's just writing it over 2. If I square it, I get 9/4. What that means is I need to add 9/4 to this to make it come out. That also means that I have to subtract 9/4 back out too. And then what we're going to do is take this piece right here as our unit. That's going to be our perfect square. Okay, now this, I pointed out this shortcut before, and it may have been more apparent because we had an even number in the middle. But this perfect square that we get is going to be x, we keep the sign, and then it's half of this middle number. So it's 3/2 squared. Now, all this other stuff is still hanging out. I still have minus 9/4, and I also have this 2 and this plus 5 still hanging out here. So you notice there's a lot of pieces to keep track of. Okay, so to finish this out, what we're going to do is we're going to distribute this 2 across these parentheses, not the square. It's just going to sit in front of the square. So we'll have 2 times x plus 3/2 squared, and then 2 times negative 9/4 is negative 9/2, right? So we distributed that 2, which means we've used the parentheses. Now I can add 5. So I need to add 9/2 to 5, right? So if I find a common denominator and add those together, let's see here. So that would be positive 10. So that ends up making it 2 times x plus 3/2 squared, and adding these two together will give me plus 1/2. So that's now my h of x. And from there we can still pull out the vertex, right? The vertex is going to be at, it's going to be the opposite of this. So it's going to be at negative 3/2 and positive 1/2. Okay, so we can actually pick out the vertex. And that's the point of being able to put it into this vertex form, or this standard form, is because it makes it very easy to graph. Because once you start with the vertex, even if you don't know anything else about parabolas, you can just plug in points on either side of that vertex to figure out other points until you have a shape. So it really is a handy thing to have. Okay, that's about as much as I wanted to give you as far as this rundown. You will actually see more examples of this as we go through the lecture in the main class. So in any case, until next time, keep your pencils and your wits sharp.